Alrighty. Well, okay. Can you hear me?
Hey there! Oh, it's a live stream now. I see. I realize. I didn't know.
Sorry,
Actually
man.
it's live.
I should have.
No, it's good. That's pretty cool. Let me retweet it.
Yeah, yeah, I should have told
I
you.
thought it would be pre-recorded, but it's totally cool. No.
No. I'm so sorry. I forgot about that. Yeah. Oh,
It's amazing.
so sorry. Oh my God, I'm so sorry. I forgot about that. Yeah, we're live.
Absolutely, no worries. It's totally fine. It's totally fine. Let's do it.
The last, I completely forgot because the last time you were on the show was like 2022, right? Or
right.
Or whatever. So in January of 2023, which feels like a minute ago, but it's actually a year ago, I started this YouTube channel, right? And
oh, I see.
Yeah, so now my practice is okay. I invite people. We do the show live, and people can ask questions, and then this is an audio visual experience, and it's a live experience. But then I take the audio, and I turn that into a podcast. So double dip.
Okay, yeah, that's cool. That's cool. Yeah.
Oh man, I'm
looking forward to it. Super excited.
So we have comments here. You can see the comments. Well, we don't have comments yet because people haven't said hello. But they will eventually. And in the meantime, we can get the show on the road. I will warn you and everyone that I am in the amazing city of Geneva, near the amazing CERN. Right, I'm there. I'm in a good place, except I'm in a bad hotel, or at least not a great hotel. The hotel has mediocre Wi-Fi, so I might actually become disconnected in the course of our discussion here, and I might have to tether on my phone, which I did yesterday with the good Dr. Subramaniam. In the interest of
fingers
preserving
crossed,
Wi-Fi,
that's gonna work out.
Yeah.
Who would have thought?
Hi, Paul. Thanks for joining us. Good on you. Okay, so can you see those comments there, Gunnar?
I saw you made an overlay, right? So I saw that.
Well, they're in the studio here. Can you see there's on the top
hold on,
right?
there's also comments. Let me try that actually.
Yeah.
Comments. Yeah. Oh yeah, perfect. I see that.
Okay, good. I'm so sorry. So my friends, this is you've been on the show before. First of all, this is your second time on the show, at least. Maybe it's the third. I forgot, but
second time. Yeah.
Yeah, and you are before the last month or whatever it was, you were most famous, I think, for your incredible work on Kafka and in Debezium and change data capture, CDC, right?
Yeah, mostly. Well, I mean, I should, to be honest, I haven't really done anything on Kafka, so I don't want to claim any fame there. But yeah, Debezium, change data capture, and this kind of stuff.
Right. And just I've said it before. You're one of the most brilliant people I've ever met. I'm really glad to know you.
Well, thank you so much.
Didn't we speak at a Kafka conference or something? What did we?
Yes, we did. We met, I believe, was it a Kafka Summit or Current? Maybe. I think I hosted one of your sessions. It's one of those.
Right.
I believe Current 22. You arrived like the last minute, like super stressed out, and I was the stage host. I also was stressing out because you didn't show up, and then oh my goodness, but it was fine in the end. It was great, great talk.
Well, I was like, there's something that didn't quite work right before the demo. You know what that's like. You wouldn't know what that's like.
Yeah, right. Yeah. I remember that. Yeah.
Maybe awesome. Maybe it was okay. I don't know. Nobody died. It's fine.
Right. We've been through stuff, man.
Well, yeah, good stuff. So then anyway, I'm a huge fan, and we talked about that stuff before. Change data capture is the idea that I can see all the messages coming off of a queue and off of a database, and then emit them as messages onto the world via queue or something else to then create my own view of it. And that pairs nicely with things like CQRS and event storming and event sourcing.
Absolutely.
Okay, so go listen to the other podcast. That's this one. You're still that in that world, but what are you doing now?
Well, actually, I'm still doing that. I mean, I maybe for folks who haven't noticed that, so I no longer work for Red Hat, where I was the lead of Debezium. Nowadays, I'm at a company called Decodable, and what we do there actually is we build a platform for real-time ETL So it takes, data from different places, takes data to other places, and processes it and joins it and aggregates it and all this kind of stuff. And of course, it's based on Debezium, it's based on Flink. So I'm still, part of the same ecosystem and universe, but with a slightly different scope. And then I do this other thing, which I kind of do on the side, which we want to talk about today, right?
Yeah. Well, so Decodable. Where can people learn about that? Is it decodable.com or .io or?
Yeah. So big important thing. It's decodable.co. So not .com, but .co. And this is where people can find us. There's free tier to try it out. So if people have this need, I don't know, for taking their data from Postgres to Elasticsearch, super common use case to do this in real time. Exactly. Everybody has it. So check us out what we do there. Okay.
And I reckon it works. It's just, I can get data into a queue of some sort, right? So
right. Yes. I mean, yes. So, in the simplest case, all this is abstracted from you. So you could just directly connect your Postgres, and then we would run Debezium under the hood. We would run Kafka under the hood, but you wouldn't even notice all this. So it's a managed service. So you just point it to those sources and things. You can do some transformations along the way using SQL if you want to. But then, of course, also you could connect it to your Kafka or your Pulsar or Google Cloud PubSub, what have you, if you already have data there. So maybe you run Debezium by yourself, running Kafka Connect yourself, then you could, connect Decodable to Kafka and then get those change events out of Kafka if you want.
So the 80% case is I'm not writing code, and if I absolutely need to, I can. You can hook it up to a sink that I care about, but ideally I can go home on, right?
Exactly. So that's the other story. So so you could just take data from A to B, doing no processing at all. You could do transformations using SQL. What is, I would say, about 80% of people do, doing some simple filtering, grouping, aggregations, joining, this kind of stuff, projections. But then also you could actually run your own custom Flink job. So if you have those super specific needs, I don't know, maybe you need to invoke some sort of API to enrich your data. Of course, you cannot really do this with a SQL statement, right? You cannot invoke REST services or whatever. So then you could deploy your own custom Flink job. And then, we would run this for you, and you still wouldn't have to take care of provisioning hardware, scaling up the infrastructure, like putting updates in place, all this good stuff.
So that is super cool. And it's obvious just from listening to, I think anybody who's listening, you're very, if there's data involved and there's speed involved and performance involved and latency not hopefully involved, there's only one person, and I can think of very few people that I want more on my team than you. You're obviously very gifted at this kind of stuff, and it's an honor to be a Java champion with you because there's a deep end of the pool and the shallow end, and
no, come on. I mean, likewise, I'm a great fan. So you're doing amazing stuff.
Thank you, Mike. But all that to say, it was not surprising when you announced, given your background with performance and all these important things, it was not and data. It wasn't surprising, but it was really cool when you announced recently the 1BRC. Can you tell us what that is?
Right. 1BRC. It was a crazy idea I had over the holidays, and then it kind of took its own life, I guess.
Was it the glue wine or the eggnog?
I don't know, to be honest. It had been on my mind for a while. But yeah, so to give context to people what it is about, so it's the 1 billion row challenge, and the idea is really simple. You have a text file, a CSV file, which contains temperature measurement values for weather stations. So it could tell, Geneva 10 degrees right now, Hamburg 15 degrees right now, and so on. So you have this text file of 1 billion measurements, and the job is to write a Java application which processes this file as quickly as possible and calculates the mean temperature value per station, per weather station, and the min and the max value. So you want to calculate those 3 values per weather station and then emit those and do this job as quickly as possible. So that's essentially what it's about.
And it's not just doing it for 10 rows, it's 1 billion rows.
Exactly.
That's the important right there.
That's the caveat. It sounds very simple on the surface, and I can tell the challenge to you in like a few sentences. But yes, it's 1 billion rows. So I'm not sure whether it qualifies as big data, but it's a reasonably large data set. If I create this file, it's around 13 gigabytes. on my hard disk. So, it's something. And well, the idea is, well, to solve this task, and then of course to learn about stuff, right? To learn how you actually can do this efficiently. How do you process 13 gigabytes of CSV as quickly as possible, and then learn about new APIs in Java, learn about programming techniques, and that's the general idea. Hey, Vincent.
Hi, Vincent. That's a really cool thing. And you had a stipulation, because I mean, there's lots of, like you just mentioned, there's Flink, there's Spring Batch, there's all sorts of things that people could use if they wanted to clutter their class path. But your stipulation was as bare minimum as, like, just one source code file, basically, or as
exactly right.
Right?
So yes, so no dependencies are allowed. I mean, because then you would just use some sort of, I know, you would call DuckDB or any library you could do for doing that. Wouldn't be that much of a learning experience, right? Because I mean, yes, so people have been super obsessed with this leaderboard and being the fastest on the leaderboard. But to me, this is just a means to an end. It's a tool which should help us to achieve this goal, and this goal is to learn about stuff. So the idea is that you should do it yourself. And also, I mean, you can, of course, take inspiration by other implementations. I mean, again, because you could learn from them. But really, the idea is that you do it by yourself, and, so you gain those capabilities and dig into all those APIs and techniques.
Absolutely. So our friend Roy, I think he was one of the first ones to send a thing in.
He was the first one. Yes, he was the first one, and I'm super grateful to him, because I mean, so this video of how to create a movement, and there's this one guy like dancing lonely by himself in some sort of beach property or whatever, and then he attracts like a complete crowd who all follow his crazy dance. And the point is that the first guy who followed him to do it, this was like the most important one, right? Because then other people saw, hey, that's a cool thing, and I also want to take part in that. And this is how this ball, gets rolling and gets bigger and bigger. And Roy was exactly the first one to do this, and he submitted something which wasn't great, but he just did it because so as to see, okay, people do submit to this challenge, and then other people came in. By now it's, I don't know, 100 or even more than 100 actually.
It snowballed almost as fast as the results of the performances of the programs themselves. The number of people went from 0 to a bazillion just so quickly.
Exactly. It's crazy, and I was completely overwhelmed, I have to tell you, because when I was thinking about this during the holidays, I was thinking, so maybe a handful of people take part, like my close friends, they might be interested. I was talking to somebody, and I'm not going to mention the name, but I was talking to somebody, and they said, yeah, you got to be careful, you got to frame it in a way so if only you do it all by yourself, that it's not embarrassing. So be ready that like nobody cares about it at all. And I was thinking about, okay, how should I do it? And then my wife, actually, she was the complete opposite. She said, this sounds cool, but you have to put something into place that you are like not completely flooded by entries. And I was whatever, who will do it? And then, well, it turns out she was actually smarter than me. I mean, obviously, because it was like so many people who did it.
Oh, it's so how many entries do we have now? I mean, it's
I haven't counted, maybe 120 or something like that. And then also it grew way beyond Java. So I mean, the thing is, I put a focus on Java for multiple reasons. First of all, I wanted to make this a learning experience around Java, so people could learn, for instance, about this new vector API. They could learn about like the new foreign memory API, all this kind of stuff. So, that was my intention primarily. And then also a practical concern. It's just, I mean, I want to run all those entries on a specific environment, and so that they are comparable. And if I were to open it up, then I would have to, install all those tool chains. I would have to, be ready to compile .NET and Rust and all that kind of stuff. And I could do it, but it would take even more time, and that's why I said, okay, I want to limit it to Java. But then we also have this nice show and tell section on the GitHub repo, where people can put all their non-Java implementations, and there's also like tons of discussions going on there. People are showing their Rust implementation and .NET,
nice.
and COBOL even, and like all kinds of databases like Snowflake and Postgres and Pinot. So we have all those non-Java entries in the show and tell, and it's also super cool to see what people came up with there.
And do we know? Well, you haven't run the alternative language ones, right? So you don't have a canonical benchmark against those.
I have not run. I think the fastest ones, they will be all pretty much on the same level. I mean, I don't think there is like super significant differences at this point in time.
Well, yeah, at some point you're IO bound, and the physics are physics, right?
I mean, people exactly that, and yeah, people are. I mean, there was the one guy I started to feel sorry. So he said, I was staring at the assembly code for produced by the Java JIT compiler for 3 hours. I don't know how to make it any faster. And I thought, man, I started to feel bad about it, because like if people do it, it's kind of my fault.
Oh no. Oh well, I mean, the results have been. I mean. So Roy's implementation wasn't bad. It just was, and he even said it, right? I remember the pull request is like, this is just a rough cut. It's a first try,
right?
And then it's just gotten better and better. Oh, hold on 1 second, Vincent. That's great. Congratulations. That's well done. Well done. I'm not even sure if I could pass that certification. That's great. Good on you. So yeah, that the results, I mean, my God, and several of them, the spirit of it was, let's use core Java. It doesn't need to be super convoluted. It's turned a little convoluted.
Oh yeah, definitely. Absolutely. I mean, it's all well at Java. I mean, many implementations use Unsafe by now. So, for instance, there could be something which might be controversial, but it's actually great to see the range of techniques people use. So, I mean, definitely SIMD, like this new Java Vector API, it's used quite a bit. But then also other techniques where you do. It's called SWAR, SIMD within a register, where we essentially process multiple bytes from an input string by putting them into a single long. So people do this kind of stuff. It's all parallelized. It's using the new memory for memory API. So yeah, people explored all those angles. But yes, if you were to look now at the fastest entries, I mean, yeah, it would definitely take you probably a little while to like really grok the implementations, and some of them on the other hand are also like really well documented. So Cliff Click, for instance, I'm super excited. He also took part. He put lots of comments. Cliff Click, he is one of the original authors of the Java compiler, and or hotspot JVM. I'm not quite sure, but so he's like an like really OG of Java.
He's at Azul Systems, right? Like,
say again.
He's at Azul, isn't he?
Cliff Click, I'm not sure, to be honest. Is he? It could be. I don't know where he is right now. But so yeah, his implementation is like really well documented, and he even did a YouTube video. So he also has a YouTube channel, and he spoke about his entry there. Definitely worth checking that one out.
Oh, I'll check it out. I'll promote it. But so before we get down into the details here, or some details,
right.
We can't go too deep, obviously. But spoil it for us. So far, was the challenge done? First of all.
No, it's still running. It still runs until the end of the month. I said, January it should be open for the challenge. I feel by now, I think there might still be some improvements right now. The fastest ones on my environment are faster than 2.5 seconds for processing that 13 gig file. And I should say I'm using just 8 out of the 32 CPU cores which I have on this environment, because I had to move environment. Right. So yeah, that's initially actually I was using a box in the cloud. It had dedicated CPU, and I felt quite good about it. Well, and then from one day to the other, like the results were completely off. It was way faster than it was before, and I was wondering, hey, what's going on? And so I opened the support ticket, and they told me, well, it's a VM, and we moved it to a different host. I know, maybe they saw that like lots of CPU cycles are burned on that machine, so they moved it to another one. I don't know what happened, but so I couldn't compare the results any longer. This was, a good learning experience for myself. You shouldn't use a VM for this kind of stuff, even with dedicated CPUs. So then I rented a dedicated server, and this is actually quite a beefy box. It's an AMD EPIC Zen 2, so not latest generation, a bit older, but it has 32 cores and 64 threads if you want to do the hyper-threading or simultaneous multi-threading. And I decided to keep it somewhat comparable to the old environment to limit this to 8 cores. And if I run the fastest entries now on that machine on those 8 cores, the fastest ones are like 2.3 seconds maybe. But actually then for the fun of it, I also ran with all the cores, all the threads, and then it's way below a second actually.
Way below a second?
Yes, it's exactly right. I mean, I should clarify that the disk I/O is taken out of the equation for this. So the way it works is I run each contender 5 times, and I discard the slowest, and I discard the fastest run. So it's sort of a trimmed mean, if you will. And so this means, the actual qualifying runs, they will take this file out of the page cache, so that disk I/O is not part of this, which is on purpose because I just didn't want to bother with disk speed and all this kind of stuff. It would have been even more complicated.
Yeah. Okay, that's amazing. So you've got this down to the point where now it's the same thing. You're not running Docker images. You're actually running the Java program, Java minus whatever.
Exactly right. Yes, and so people need to prepare like a launch script and another script which sets the environment, because this is also something which I wanted to explore. How do different Java distributions fare in this contest? So I know, there are some distributions which use Graal as a JIT compiler. There are some distributions which might already have this crack API, right? So a checkpoint and restore. There might be, maybe somebody wants to use a Java 22 EA build for Valhalla or whatever it is. So I wanted to open up, or specific garbage collections. I wanted to open up this space so people could run with different Java builds, and also, of course, with ahead of time compilation. And so we use SDKman for that, and within their prepare script, people need to specify which Java build they want to run with using SDKman, and this is then how it gets executed.
Okay, and of course, you're not going to just run arbitrary code in your machine without looking for anything obviously.
Yes, I take a look. I mean, I don't want to run people's Bitcoin mining code or whatever it is. So I take a look before I run it.
Yeah, and that's the nice thing about having no dependencies. It's pretty self-evident.
Exactly right. Yes, exactly. And that's also why, it should be like in one file, so I don't have to check like a gazillion of source files, to make it just a little bit simpler for me.
Love that. Okay, so let's talk about that. You mentioned this a couple times already, but let's kind of like background some of this stuff before we look at the results or talk about what they mean.
Right.
You mentioned we mentioned Java 20. So you mentioned Java 22. There's Valhalla. There's also Project Panama, where you get the vector stuff, and you get the native code support as well, like a JNI++. What is that stuff? What is the vector API, for example?
Right. So vector API is particularly interesting because quite a few entries use this. So essentially, it's about allowing Java developers to make use of what's called SIMD, which stands for Single Instruction Multiple Data. So essentially, those are CPU instruction set extensions which allow you to do exactly that, right? Apply the same operation onto a multiple of operands at once. So let's say, you want to just do an addition of multiple values, and you have those in an array. So you have 4 values in one array, 4 values in another array, and you want to add up like the first 2 ones, the second 2 ones, and so on. So you could do this essentially using a single instruction using those SIMD CPU instructions. And now this, of course, is heavily hardware dependent, right? So this would look different on x86 versus, for instance, ARM. So you would have different instructions there, and I mean, you just couldn't, in Java you couldn't specify, okay, I want to use a particular instruction, right? It's just not what Java is built for. But now with this vector API, you actually can do this because it's a high-level API which has Java methods, and then they are compiled down into those instructions, and they allow you now to take advantage of those SIMD instructions.
And that's coming, is that GA in 22? I think it is, but is that still true?
It's still, I'm not sure about 22. In 21, it's still like the 6th or so preview. I feel it's definitely the API with the most preview or incubating steps. And I'm not sure about 22. It might be stable there. I'm not quite sure.
I think I saw it, but I could be wrong. Don't quote me. But Project Panama there's the vector API, which you just talked about. There's also the
right.
Like for me, I'm looking for JNA and JNI++. That's what the big thing is.
I see.
You know,
yeah. And
that's
so
cool.
I haven't seen anybody using JNI so far. The reason being, so the rules say it should be in Java, right? And the source code you do should be in Java. And now with the JNI, the traditional way you used it, you always had to write some sort of glue code in C or C++, right? So like the native counterpart, whatever. And so you couldn't do that. But actually, I learned that with GraalVM, you can do this. You can essentially create native libraries from Java code, which are then compiled ahead of time. So you could invoke those using JNI. Nobody has done this so far, but what people have done is just using GraalVM ahead of time compilation to just produce a native binary.
Okay, so let's talk about that then. We're just going through the terms here.
Right.
You've got the regular JRE, which is the Java runtime. It has a just-in-time compiler, which in response to lots of runs, only after whatever 10,000 or 100,000 runs, will retroactively compile things into native code.
Right.
But the problem is that there's that warm-up period, and if you're benchmarking for speed, you might want to get that native code ahead of time. And so there's also this project called GraalVM, which has a native image compiler that does ahead of time compilation. Are you saying that there are native images being submitted?
Right. Yes, absolutely. So that's the case. And I kind of went to this. Can I come to Dev Nexus? Let's talk about it. When is it? I don't know. When is it? I would love to. I would love to do it. So the thing is, I didn't expect that we would get to the single digit seconds range. I did not expect this at all, because initially I created a let's call it a naive baseline implementation, and this one runs.
Right.
It does the job like in 5 minutes or so, and it's kind of embarrassing because with that one I'm the last one on the leaderboard for all time. It's fine, so nobody submitted anyone which is actually slower than that. So that's my baseline, and this ran for 5 minutes, and I totally had never expected that we would get to like 2 seconds or whatever. And now with the GraalVM native binary. So yes, you can then, of course, shave off those, 100, 200 milliseconds maybe in terms of startup time improvement. And now if you look at 2.5 seconds overall, well, then yes, 200 milliseconds actually do matter, right? So that's an interesting thing, interesting observation. But also, there's actually a very fast. There's also a very fast Java entry, or JVM entries still, definitely. So like the 5th or so, it's plain JVM, and
really?
The reason yes, it's doing really well. The reason why that is some of the SIMD stuff which they use, it's not optimized in GraalVM just yet. So actually, then GraalVM wouldn't. Benefit from it. And then also actually many people use GraalVM just as a JIT, as a just-in-time compiler, and still are on the JVM.
C2, right? Like
exactly right
replacement. Yeah, and that's another and that we've do you remember our old friend oh gosh, forgive me, he was on the show too. I'm having a jet lag brain fart.
What's
a friend
doing?
From Twitter who retired, who worked on GraalVM.
Oh, Chris Tullinger, I guess.
Yeah, thank you. He was out, I remember seeing the numbers from that. Just running on the GraalVM JIT itself without native images was also whatever 10%.
Absolutely, yes.
That was amazing.
Yes. And I think it depends on the workload, right? So you want to check whether it makes a difference. But yeah, it seems for instance now for this particular workload, it seems it's an improvement for many of the implementations, and you kind of get it for free, right? So definitely worth something to explore. Which also was an interesting insight for myself. It's worthwhile just to try how you fare by using GraalVM as a JIT, and you don't have to change anything for that new code.
And it would be kind of interesting to set up like a matrix and maybe do like just you somehow, if you could like run all the Java programs on Azure versus
so
Graal versus
I
whatever.
guess one could do that, and people have asked for that. I mean, it's just so much effort, and I felt, okay, people can choose their JDK, they can choose, do they want to do a JIT or AOT? It's documented in the leaderboard, so you know what it is. And, I mean, in the end, the task is, okay, solve this as quickly as possible and use the tools you want to use. And I felt, that's the way how the challenge is set up right now. But yes, you could totally be more scientific about it and like compare different things and so on.
Later. Okay,
later,
so
exactly.
I bet you want to just get through the tournament first, right? Like,
exactly. Yeah, exactly.
It's so good. So okay, GraalVM is I'm really impressed, duly impressed. Like several of the top 3, I think the top 3 are all native images, right? GraalVM.
Yes, by now, yes.
Centric, which is a ringing endorsement for GraalVM. I mean, if you really want startup speed and decent runtime,
totally. And people asked, by the way, so I got all kinds of theories. So, hey, is this an engineering problem you guys had at Decodable and you wanted, you outsourced it, so the community solves the problem for you? So no, it's not that. It was just a fun experiment I had. Then other people asked, so hey, is this like a hidden ad for GraalVM? And no, I'm not on the payroll for by Oracle. It's not. I just wanted to put this out in front of people, and it's just great to see what happens. And if GraalVM does well there, I think it's an interesting learning for me and for everybody else.
And then okay, so what else do we see? The Unsafe. That's our old friend Sun.
Yeah, this one is interesting. So this one happened maybe over the last week or so, and actually that's also interesting because like people, they look what's going on in the other implementations, and at some point somebody started with Unsafe, and like now everybody's using Unsafe. It's a bit like that. So yeah, this essentially allows you to directly access memory without like access checks and this kind of stuff. So it's a bit faster. It's unsafe. If you do it wrong, you could, your program could crash. Roy did a very interesting tweet about his experiences there, where he had like 50 log files from where his JVM crashed while he was working on his unsafe implementation. But yeah, so this also gives an advantage here, and it's actually interesting to see because it is supposed to be removed, right? I think it just got deprecated for removal recently. So this is an interesting aspect, right? So yes, so can we replace this actually? And I'm not quite sure whether all the usages which we see right now could actually be replaced with other supported APIs.
Wow. And then what was the stuff that so I mean the unsafe stuff, I don't think all of it's going to be removed, right? I thought some of it would always just be there.
Right, I'm not quite sure. I think there should be like, there's like var handle APIs, and I'm not super deep on this stuff too. There should be replacement APIs for it, but it's my impression that at least right now there's not an equivalent replacement for everything in Unsafe.
Right. No, I didn't think there was. I just think they didn't. Okay, I could be. Yeah. Either way, the stuff that a lot of people are depending on is certainly going away.
Right.
And then Thomas Wertinger, the GraalVM founder, also guest on this show. He submitted an entry, and he was doing something with what's that thing I saw he was doing? Unloading.
The unmapping of the file, yeah. So this was also very interesting to see. And again, it's now like all the top 3 or 5 or whatever all do the same thing. So yes, what he realized is that
they're learning. they're improving off of each other. It's like a race to the top.
Right, and that's totally fine, right? I mean, there's even like one of the so Thomas actually teamed up with some others, so there's like multiple authors for this submission, and that's exactly right. I mean, to be honest, I don't care who is the fastest. What is the most important to me is like, that we all find out about this stuff and that we can learn something. But yeah, so what he found out is that so I mean, most of the people, they memory map the file, so they can then directly access it from off-heap memory. By the way, there's also
Unsafe.
yeah. So I mean, you don't have to do this with Unsafe, but yes, you could use Unsafe then to access that file. But there's also like of other APIs. And by the way, I should say there's a new API coming, or it's even there already for a memory API, which then, for instance, allows you to memory map this entire file at once. And before, in previous Java versions, you only could memory map up to 2 gigabytes. So you couldn't have mapped this entire 13 gig file at once. Now you can. But yeah, so people memory map the file, and what then they realize is that actually unmapping it takes quite a significant amount of time. So when you stop the application, it takes, I don't know, maybe 200 milliseconds or something like that to unmap the file. And again, if you look at 2.5 seconds, 200 milliseconds is like almost 10%, right?
Yeah.
So it's significant. And essentially what Thomas did, he found an elaborate trick where he could have a separate process. So he spawns a separate process, and then the outcomes, like the mean and min and max values, they are reported by the first process, which then already can terminate, and the unmapping is done by the separate process, which runs a little bit longer, but it's not part of the measurement anymore. And I was a bit on the fence if is this like legit, or is it like I mean, yeah, surely it is a trick. But then actually I felt, okay, I guess it's something you could do and you might do if you have this task for real. And I hadn't provided any rules which like would forbid that. So I said, yeah, sure, okay, let's do it. And then Thomas did it, and like 10 minutes later, Roy had the PR up with the same trick, and like Artyom, another guy, had like his implementation updated like within a few minutes after. I had not even merged Thomas' PR; they already had theirs up with the same trick.
I love this community so much. Oh, that's so cool.
Yeah, exactly, and that's what I love to see. And it I have to say, it just sparks a deep sensation of joy for me to see how all these people, are nerd sniped by this, and they look into this, and they keep exploring it and have fun with it and inspire each other. And for me, it's just a great feeling of joy that I can witness that.
Yeah, and it's joy for us because it's just really cool. And by the way, for people who are I mean, I'm actually at CERN, right? I'm speaking at this conference called Voxxed Days CERN. Hi, Voxxed Days. Thanks for everything. And there's you no doubt know this, but for people in the audience, I don't know if you've heard about some of the crazy things they do here. They have these particle colliders, and they slam these particles into each other, and that generates a lot of data, petabytes of data over time, and they have to process that stuff. And they got to the point where it's now like, okay, they're using GPUs, they have CPU clusters as well. And some of that is actually Java, which is, it's crazy. They're doing really amazing things with these commodity tools, and sometimes commodity, they have a lot more money than most people do to solve the problem, but they're still using stuff that a lot of us would know how to work with, and it's pretty impressive. And then you can see this is a much more, what you're talking about is a much more reasonable sort of normal.
Right.
Like,
and which I also think is part of the why it's so attractive, apparently, because it's it's a deceptively easy problem, right? So I can explain it like in one sentence to you, and still it provides so many angles and potential to explore it, which is why I believe it's so interesting. By the way, there was an interesting question from Vincent. Does crack make it to the top 10?
Good question. So what is crack?
Exactly. So crack, it's hope I say it right. It's a checkpoint and restore. So essentially, the idea is, you freeze the state of the JVM. And Vincent, correct me if I'm wrong. I hope I say it right. So you freeze essentially the state of your JVM in your program, and then you can load this up again, and the startup will be much faster because it doesn't have to do like the class loading and all this kind of stuff. And long story short, I don't know, Vincent, because nobody actually has submitted something on Crack yet. But as I learned, there is JDK builds which support Crack available via SDKman. So anybody could come and create their entry and try with Crack.
So it's coordinated restore at checkpoint, and it's what you said.
So much.
It's based on a Linux technology called CRIU, CRIU, and it's basically the idea of like what you just said. You can take any binary, take a photo of it when it's running, dump it to disk, and then load that disk into some other node and just skip all the initialization. And they found a way. Azul Systems led the effort, and they've found a way to load a JVM program. And you even have a life cycle. Spring Boot 3.2 supports that, by the way. For those of you listening, you can take care of this too. So now I can have a Spring Boot app that starts up in less than a second on the JRE. I use Project Crack. Now it's like 5 milliseconds. It is.
Okay. Yes, I need to try it out. I mean, I haven't played with it. And I mean, there's many interesting challenges, right? So you got to like change like your randomness seed, and if you have like IP addresses and what this kind of stuff, you need to like change this, right?
Oh yeah. But are you running this box that you're running the examples? This Linux, surely.
Yeah. So somebody could try it out. I mean, I would love for somebody to give Crack a try.
And somebody asks,
and hence to answer the next question. Yeah, I think I've seen you in a Debezium presentation. Yes, that could certainly be the case. I mean, I have been the project lead for Debezium, and I have done my fair share of Debezium talks.
Yeah,
thank you for joining.
Yeah, I'm super glad when people recognize the guests because, and then you're a celebrity for so many different reasons. Let's see. Well, how many participants took part? You said there's 120 something, whatever entries, right?
So actually, let me just take a look. Like 45.
It's on the GitHub.
Yeah, 120 something at this point. 125, and there's like 10 PRs or 15 PRs pending. So yeah, it's going close to 150 or something.
100. You're maintaining a separate. Well, at least it's a time boxed open source project, right? Like you're busy merging PRs and managing code quality.
Yes.
And
right. And also I should say actually that's a good segue. I want to give a huge thank you to all people who helped with it, because of course, like there are many people who want to participate and they do it, but then actually also people stepped up and volunteered to help out with running it and improving the experience for operating it. So there was René who helped me with setting up this new environment and making sure it's like configured properly. Somebody else was helping a lot with all the scripting around evaluations, so that I run all the tests and that it creates like the proper leaderboard results and everything. So this was a huge job. Thanks for that. And also like just creating tests. I mean, to be honest, it was a little bit under specified in the beginning, and then of course people asked about all kinds of corner cases. So like what are the value ranges and how many stations can there be? All legit questions, and it's now all legitimate questions, and it's all specified now. And people contributed tests around it, so now there's like a bit of a TCK, you could say, which you need to if a new entry comes in, it actually needs to pass this TCK, and then it can go into the
oh, that's so cool. And I noticed all the files are named main or whatever dash and then the username or something.
Right, yeah, exactly. And then it's all in the same directory, so that's it's not ideal. So now there's like 300 files or whatever in the root directory of that repo. But I mean, I'm also doing this for the first time, so whenever I would do it like another time, I mean, I'm sure there's many things one could do different. But yeah, it's I think it's still a fun experience.
It's so good. It's so good. So what if you had to for me the takeaway is Java is amazing. First of all, just the fact that
it's super competitive, and I mean, that's still this, in my opinion, stupid trope like Java is slow and yada yada yada. And I think it clearly proves it's not the case. And also, I mean, one very interesting observation is I mean, you mentioned it, right? If you look at those top entries, they are like really dense code, hard to read, and I suppose hard to maintain. And if Roy doesn't want to maintain his one BRC entry any longer, and you have to take over and maintain his entry, or I would have to take over and maintain his entry, we would probably have a bit of a hard time doing so, right?
Right.
And
Right.
and this is true for those first, like, those very entries at the very top. But what I also observed is, I mean, my own baseline implementation, which was like completely not optimized, and then if you compare those which are like one order of magnitude faster, so which run like 20 seconds or something like this, they actually can be very well readable. So it's code, I would write, you would write, everybody else would write. It's still just not doing the most stupid mistakes. It's, taking advantage of like parallelism, maybe be a bit smart about how you parse the stuff, but it's nothing fancy. So you can read those implementations very well. But then if you get another order of magnitude faster and you are at the top, this is where, it's becoming like really weird and crazy. But I felt there's an interesting balance to be made, right? So if you put in a little bit of effort, so you can maybe quite easily get an order of magnitude of performance, and it's faster to run and cheaper to run and so on. And everybody actually can do this by paying attention, essentially.
Yeah, and when you say an order of magnitude slower, that's still, like you said, 20 seconds for a billion rows doing
exactly,
something
right.
useful.
And that might be good enough for most use cases, right?
Yeah. I don't know, like if you think about your average, like does Amazon.com have 1 billion customers? I don't know, but like
yeah, I don't know. I mean, I'm sure they have data sets of that size, or surely even larger, and then it can make sense if you have like a very focused core team or if you implement a database. Yes, you want to squeeze out every little bit of performance, but in many cases you don't have to go all the way there, right?
Well, exactly. 1 billion is a lot. It's a big number. It's atypical to have 1 billion of anything in a program, So the fact that we can do it, good. Golly, it's amazing.
Yeah.
I don't know. And then you in Java 22, or I think that's the version that is with the vector support and Project Panama. Whatever. Maybe if it's not that, it'll be the next one. But it's soon. The fact that you're talking, all these entries are relying on things that are either already GA or very soon will be GA.
Right.
For some definition, soon. That's. We live in a wonderful time here.
Yeah, absolutely. Also, some people took advantage of Epsilon GC, which is like having no GC at all, which I also found very interesting, to process a 13 gig file with a heap size, I don't know, of maybe 256 megabytes and not requiring any GC. And that's pretty cool, right? And I mean, the way that, it could be done off heap, or it could be done by just like, being smart and not allocating things, like reusing arrays and so on. So I found this also super fascinating to see. Alex Shiplev is, I believe, working on an implementation around Epsilon GC. So he also is taking part, actually.
Alex is great. He's the one who, I remember he even tweeted about Epsilon a few years. This is not even that long ago. This is like the last 5 years, right?
Right. Yeah. I think he created it initially, right? He added it.
Right, and it almost seemed like a joke, but he's like, no, it for Lambda it makes a ton of sense. Just make a mess and then destroy the process.
Yeah.
Then
off you go. Right.
Yeah, it's fine. And now it seems even more useful, like for this kind of thing. And this would be a Lambda kind of situation of scale to 0, start it up, do a thing,
yeah,
then
right.
That's exactly. So cool. I love the versatility of the ecosystem. I think anything else we should know? Anything else you would love for people to appreciate?
Let me see. Yeah, I wanna give a shout out to Decodable, my employer, because they actually sponsor this environment which this stuff is running on. So big kudos to Eric and our CEO and Decodable. That's great. Again, a big shout out. To everybody who participates. It's great to see all the implementations. Thanks a lot to everybody who helped with running it. in the second week of January or so, I was kind of swamped, and I didn't do anything other than just like evaluating one BRC entries from dusk till dawn. It was like and people helped a lot to make this much smoother. So yeah, it's just great to see how everybody is engaged with this, either by participating or by also helping to run it. So big shout out to all the people involved.
Here. Do you have any other challenges you're thinking about dropping on the community, or is this it for the I think there's a lot to learn.
Well, this is it for the for the near future. I mean, people ask already, hey, what do you do like next time? What's the challenge next January? And oh man, I'm not sure whether I want to ever do a challenge again. But yeah, I could see it. I mean, I have to think about it. I think, if actually it would be a team which runs it from the get-go, and we would have to be like really precise, more precise than it was now about like all the rules and the like corner cases and all this kind of stuff. And ideally it would be like fully automated, how you evaluate it, and people could just, I don't know, submit a pull request and it would run on some environment, and they could get a runtime for themselves. So if we could do all that, and it would be a bit less manual effort, I think I would be up for doing it again. And I know it would certainly be a problem in the data space, because that's what interests me. But I haven't really thought that much what it exactly would be if I want to do it. For now, I'm just focusing on surviving that one.
Yeah, I'll bet. Well, thank you for sharing. Thanks for the effort. Thanks for sharing the insight. And I look forward to seeing you. And you should probably get back to Vincent.
Yes, I will follow up. Winston, let's talk about DevNexus. Let's talk about it. Thank you so much.
I connected you two on X, Twitter, whatever.
That's it's amazing.
Hopefully I'll see you in...
Thank you so much for having me.
Thank you. Bye, everybody. Have a good one. And then stay tuned, actually. I mean, you can disappear for like 20 minutes, but I got another one coming up in the next 30-ish minutes, so don't go too far. Thanks, Gunnar.
Cool.
Bye.
See you.